Hello everybody, welcome to my talk today. It's called High Performance Reactive Applications with Vertx. My name's Tim Fox. I'll say a few brief words about myself. I'm currently employed by Red Hat, where I lead the Vertx project, unsurprisingly. I've worked in open source exclusively for the past 9 years of my career or so. Some other projects I've been involved with, other than Vertx, I worked with the RabbitMQ team for a while at Spring Source. I'm the creator of the Hornet Queue messaging system, which is a messaging system at the heart of JBoss application server, and various other projects. Right, so why are we here today? Right, so this talk is going to be, it's kind of an overview talk about Vertx. I'm also going to dive down into some of the more interesting features and do a few demos as well, so it's not too boring, hopefully. So how many people here, just a show of hands, have used Vertx before already? Okay, a few people. How many people are familiar with Node.js? Okay, so you've got a kind of context point there, right? So what is Vertx? How do I describe it? It's a lightweight, reactive application platform. It's lightweight in the sense that it has a very lightweight runtime footprint, but it also has a very small distribution. It's reactive, so I'm sure you've heard this word reactive a lot at this conference, right? It's kind of been the theme of the conference. So what do I mean by reactive? And I'm kind of using the definition the TypeSafe guys have been using, right, in the reactive manifesto. So what I mean by that, it's event-driven, resilient, scalable. You know, I think there are 4 points on their axis. It's pretty much that definition. Now, none of this is new stuff. This has been around for years, right? It's just kind of a new buzzword for kind of stuff. Event-driven systems have been around a long time. So Vertx, when people think of Vertx, they often say, well, that's the Node.js for the JVM project, isn't it? And that's kind of true to a certain extent. Certainly, when I first started Vertx, one of the sources of inspiration was Node.js. But I thought, OK, some of this is pretty cool, but other bits I don't really like so much. And I think we can actually do it better on arguably a better runtime, the JVM. And also, we can do stuff like, maybe you don't want to just program in JavaScript. What about other languages? Maybe you want to do the same sort of thing or similar kind of stuff with other languages too, which you can't do with Node.js, right? Another source of inspiration was Erlang OTP, from my days with the RabbitMQ team, where I learned that. In particular, the actor model, which I'm sure you've heard a lot about from especially Akka and all that kind of stuff as well. So that's definitely another source of inspiration for Vertx. So we have a kind of hybrid kind of system. It's kind of like a cross between Node.js, Erlang, all mixed up, and Polyglot, right? And I'll talk about that in more detail later. It's high performance. Anyone can say high performance, right? So, I mean, there's a set of benchmarks out there right now called Tech and Power benchmarks. How many people have heard of Tech and Power? Okay, hardly anybody. But anyway, it's a company, not affiliated to Red Hat or Vertx at all. They've done a set of benchmarks across pretty much every framework or platform out there, not just JVM stuff, like Rails and Node and all that kind of stuff. I can actually show you some results from their last round. And as you can see, they've benchmarked loads and loads of stuff, right? This is a basic HTTP benchmark, and Vertx is right at the top there compared to everything, right? So we're not just comparing JVM stuff, it's like C stuff, it's, Node.js, for a bit of information, is right down here. There we go. Okay, so like 8 times faster in terms of those kind of raw HTTP benchmarks. So that's what I mean by high performance. Yeah, we're polyglot, so kind of a unique feature of Vertx compared to pretty much any application platform out there today is we're very truly polyglot. We support a lot of different JVM languages, and you don't really find that with anybody else. And again, I'll talk about that more in the next slide. And finally, on the sort of overview kind of description stuff, simple but not simplistic. So one of the major motivations of Vertx, we're trying to get away from this kind of perceived complexity of traditional application platforms. By traditional, I mean kind of Java EE kind of stuff, complicated XML configurations and packagings and all this kind of stuff. Moving away from all that. So we want to give the developer a lot of power to do real stuff, but very, very simply, running it directly without all this kind of baggage that comes with it. So that's another source of inspiration for it. Yeah, so polyglot, right now we support obviously Java, We support JavaScript, actually 3 flavors of JavaScript. We support Nagiorn, the new JavaScript engine in Java 8, and Rhino and Dyn.js, which is another runtime from Red Hat. Ruby, Groovy and Python, well, Jython, sort of Python. And also we're almost there with full support for Clojure, Scala, and Salon, which is another language from JBoss Red Hat. We actually also have PHP support too, if you like PHP, which probably, well, anyway. Okay. Right, so if you've, most of you have probably played with Node.js or maybe written an application of Node.js, so you're familiar with how applications are written in that kind of world. There's quite a small set of asynchronous APIs that you develop to. And those APIs do kind of low-level stuff like HTTP and TCP, lets you write clients and servers. And it's the same with Vertx, right? So we have HTTP, TCP support, we have full WebSocket support, we have SockJS support. Who's heard of SockJS? Okay, so for those who haven't, it's similar to kind of like Socket.io, which you get in the Node world. So it's a way of providing like a kind of WebSocket-like API on the client side, even if your browser or the network doesn't actually support WebSockets. Maybe you have a proxy or something. So it falls back to one of many different transports depending on the capabilities. So we have full support for that. And we have kind of like asynchronous file system support and various other stuff. One thing that's a really important feature of Vertx is the event bus. So this is kind of, in my view, probably the most important feature of Vertx. And the event bus is the thing that joins everything together. And we'll get onto that in a bit. So why asynchronous? So, arguably, if you're developing to asynchronous APIs, so I mean event-driven kind of APIs, right? And I'm sure most of you are familiar with that. Then you're probably also familiar with that, arguably it's more difficult to deal with asynchronous APIs and kind of synchronous blocking APIs in terms of, reasoning about the control flow and debugging and testing and all that kind of stuff. And that's not necessarily true in all situations, but it is true in many situations. So we don't want to force you to use asynchronous APIs unless there's a good reason for it, right? So what is that good reason? And it's all about being able to handle a lot of concurrency. So many applications today, especially server-side applications, but not exclusively server-side applications, need to handle a high level of concurrency. Now, not all applications do. Some applications never have much concurrency, in which case maybe you don't need an asynchronous programming model, and that's fine. But kind of a lot of modern applications, like say you're writing a web server, maybe a WebSocket server, maybe an online game, all this kind of many different examples, they often require a lot of concurrency. And that concurrency may be because, for example, they have to handle a lot of connections. A lot of WebSockets are long-lived connections. In the world of IoT, Internet of Things, you have protocols like MQTT, also long-lived connections, right? So this kind of requirement to handle more and more connections is kind of not going away. In fact, it's probably going to be more and more of that around. So any server you write needs to be able to handle all these connections without using a lot of threads. Because even though threads are a lot more lightweight than they used to be, there's still a lot of overhead in terms of the stack space for each thread, but also the context switching overhead. If you're constantly context switching, you soon get bogged down. So this kind of leads us to a non-blocking approach for I/O, and that naturally then leads us to non-blocking asynchronous APIs. So that's why we do it. And like I say, it's not appropriate. Asynchronous is not necessarily appropriate for all types of applications. I'll be the first person to say, if you've just got a little application that has like no more than 10 connections, then you don't have to use asynchronous stuff unless you want to, right? Right. So let's talk about how do you actually write a Vertx application. So any Vertx application is composed of things called verticals. And the vertical is just a lump of code, and it's the smallest execution unit of Vertx. And a particular vertical can be written in any of the languages that Vertx supports, so Java, JavaScript, Ruby, Groovy, Python, Scala, Clojure. And a particular vertical instance is inherently single-threaded. There is actually an exception to that, but it's a kind of advanced feature. I won't get into that right now. But you can assume, in most cases, they're single-threaded. So you have all these kind of single-threaded bits. comprising your application. And the way they talk to each other is by passing messages using the event bus, which I mentioned earlier. So you're probably thinking at this point, if you're familiar with the actor model, it sounds a bit like the actor model, doesn't it? Kind of your verticals, maybe they're kind of a bit like actors, single-threaded. You don't have to worry about those concurrency, multi-threaded concurrency issues. And the way you scale it is by having lots of them, and you kind of send messages between them. And yeah, it is very similar to the actor model. So in terms of our approach to concurrency, the Vertx approach is very similar to the actor model. We are not a strict actor implementation. However, there are similarities. That's a good thing. OK, so let me show you a couple of what we call raw verticals. So let's go into Hello World directory. Can you see that OK? Cool. So what I've got here, I've got a couple of files, and this is what we call raw verticals. So there are two verticals there. And raw verticals are ones that you run directly at the command line. And this is really useful for kind of prototyping and doing, quickly getting stuff running without having to worry about build scripts and all that kind of stuff. So let's have a look at the JavaScript one first. So we have a Hello World JS. So let's open that up. Oh, it's been truncated. I think my resolution's not quite right. But it's a very simple Hello World example. And again, if you've used Node.js before, you're kind of familiar with this sort of thing, right? So we're just creating an HTTP server. We're setting a request handler on that server. And the request handler is just a function. And that function is going to be called when a request comes in. And when a request comes in, we're just going to output Hello World from JavaScript, which unfortunately been truncated. Let me just see if I can change the resolution there. OK, it's better. Yeah. So yeah, pretty trivial Hello World example. Let's actually run that. So the way you run it with Vertx, again, similar to Node, Vertx run Hello World JS. OK? And it's running. We go to our browser. Let's go to localhost 8080. And there we go, it's running, kind of unsurprisingly. Right, so let's go back to that example. And in the same directory, I've got the same example, but this time written in Java. Now, this is written in Java 7, and this becomes a lot nicer in Java 8 because of lambdas, right? So be prepared. OK? Same example. Again, Java's not a scripting language, so we have to create a class with a start method. And again, doing the same thing. We're creating an HTTP server. We're setting a request handler. Now, because it's Java 7, the request handler is an interface, right? So in this case, we're providing an anonymous class, basically, to provide that handler. And when that request comes in, we're just going to say hello world from Java, like we did before. Now, of course, with Java 8, this becomes a lot nicer, because instead of anonymous classes, you can use lambdas, right? So Java 8 is a really good thing for Vertx and any other event-driven, event-style system, right? Because it's a lot nicer to code with Java 8 than Java 7. And I actually see this as becoming, I think Java 8 is going to, because we're kind of looking at a more reactive world now, the fact that Java 8 has lambdas is a really good thing. And it's going to really help Java 8 as well. So let's actually run that, shall we? OK. So again, right. This is a Java source file, right? So we've got to compile this first into a class, right? Aha. No, you don't, actually. You can just run it directly with Vertx. OK, go back to the browser, and it's running. Yeah. So it's a kind of nice feature of Vertx. We're kind of doing quick prototyping. It'll actually compile the Java on the fly for you. So you can kind of almost just play with Java files without having to worry about creating a build script and all this kind of stuff. It's quite a nice feature. Of course, you can run Java classes too, if you want. And in kind of bigger applications, you typically would have Java classes. OK, so that's Hello World. Right, let's talk about the event bus. So I mentioned earlier, the event bus is a very important feature of Vertx. So what is the event bus? It's a nervous system of Vertx. So you have all these things called verticals, and they talk to each other by sending messages over the event bus. So what is it? So really, the event bus is just an asynchronous messaging system, right? And it is a transient asynchronous messaging system. So we don't do persistent messages, anything like that. but we handle point-to-point messaging, we handle publish-subscribe messaging, and request-response messaging. And what can you actually pass over the event bus? You can pass, all the usual stuff you might expect: strings, primitive types, buffers. All the stuff has to be immutable, though, and if it's not immutable, Vertx will copy it, right? Because we don't want a situation where you're passing something immutable from one vertical to another, and then it's being modified concurrently by two different verticals, because then you've got race conditions and all that, We're trying to get away from that kind of world of mutable shared state. One thing we kind of recommend for passing between verticals is JSON. And the reason we recommend that is because of the polyglot nature of Vertx. So you may have a vertical written in Ruby over here, talking to a vertical written in Scala or Java over here. And if you've kind of passing, say, some sort of binary formatted thing, that might be quite hard to parse and create in different languages, right? The one thing that's really easy, it's really well supported and really easy to parse and support and to create in all these languages is JSON. It's well understood. So we recommend JSON as a convention for passing between verticals, a kind of lingua franca of Vertx. It's not a strict rule, but it's kind of convention. Okay, so this event bus, allows verticals in a single JVM to talk to each other. But we actually can take it a step further, and the event bus actually extends to different JVMs on the same network. So it allows all your verticals, irrespective of where they actually live on your network, to talk to each other in exactly the same way, just by referencing them by a simple address. So actually where they live is completely transparent, right? They could be in the same JVM or a different JVM. The way you talk to them is exactly the same. So the event bus is actually a lightweight peer-to-peer messaging system, which connects all these different JVM instances, which can live anywhere on your network. So we're kind of moving toward this kind of vision for creating applications. It's getting away from this kind of application server model. So with an application server model, you have a kind of thing called an application server, which sits somewhere, and then you deploy stuff into it, right? Then it runs. With Vertx, you don't do that. There's no application server. You write your stuff and run it directly wherever you want to run it. And then it talks to other parts of your application, wherever they may be. Maybe they are on the same node, that's fine. But maybe they're in different nodes, different parts of your network in a loosely coupled way by using messaging. So it's a bit like the kind of, we heard a lot of microservices recently. I kind of tend not to use that word too much, but it is a similar kind of approach, right? And obviously, you don't want your services to be too fine-grained. What we don't want to do is get into this kind of bad old world of distributed objects, right? So we're not talking about fine-grained distributed objects, because it's not good, right? Yeah, so the clustered event bus. The event bus allows all your, verticals on the server side to talk to each other. But we can take it a step further still and put that actually into the browser as well. So you can use the API used on the server side, you can actually use exactly the same API on the client side too, in client-side JavaScript, to interact with the event bus. So now you have a situation where you have peers. They can be on the server side, or they can be in the browser. So you have browsers talking to servers, servers talking to browsers, servers talking to other servers, all location transparent. And this is kind of, it makes Vertx a kind of really good choice for so-called real-time web applications. By real-time, I don't mean the kind of computer science definition of real-time that I was brought up with, as in hard and soft real-time. I talk about the kind of modern webby definition of real-time, which basically just means pushing stuff to browsers in a reactive way, right? And on the client side, you can use Vertx with whatever client-side toolkit you already use. So, AngularJS, Ember.js, Knockout, whatever. It works everything. So let's actually have a look at the event bus then. So let's close down the previous example. OK, so I have another directory here, and we have some more verticals in it. I've got one called receiver.js, so another JavaScript vertical. Let's take a look at that. And it's, again, a very simple example. This example is going to basically do a little bit of, it's going to do the subscribe part of publish-subscribe messaging. So it's registering a handler against an address, which is just a string, could be anything. In this case, it's called newsfeed. So it's subscribing to that address, basically. and it's providing a function when it subscribes. And that function will be called whenever a message arrives on that address. And when that message arrives, it's just going to log it out to the console, right? So it's just subscribing to, you know, a news feed. So let's run that. So this time, I'm going to say Vertx run receiver.js. And now we're going to add a flag called cluster. And what this does, it says to Vertx, when you start up, I want you to look out for any other vertexes which might start up on the same network. And if they do, then I want you to cluster with them to form this kind of distributed event space, right? Let's hope it gets the right IP address. OK, so let's go to another window. And so we just run the receiver. So let's run a sender as well. So for a bit of a variety, let's do a bit of Scala this time. So I've got there's actually a Scala API still in flux, so it's not necessarily a final API, and it can be improved in some areas. But here we have a simple vertical written in Scala. And again, very simple. All it's doing, it's setting a timer to fire every second. So every second, this timer will fire, and it's going to basically, every second, it's just going to publish a string to that same event bus address, right? So it's doing the publish part of publish subscribe messaging. Now with Vertx, you can run directly both Scala source files and compiled Scala classes, right? Do either one you want. So the Scala API, is, like I say, is not complete yet. It's been written by Galder Zamoreño, who works at JBoss. He's our kind of resident Scala expert. I'm not particularly a Scala expert, so Vertx run sender.scala. Again, we're going to run add the cluster flag, okay? Let it cluster together. Okay, so it's compiling that bit of Scala on the fly. Right. If we go back to our receiver, you can see it's picking that up now. So every second, it's picking up the same thing. So this will work irrespective of where those things are on the network, right? So it's transparent, location transparent. So let's take that a little bit further and extend that to the browser too. So if we're going to extend it to the browser, we need to serve a page to the browser. And if we're going to serve a page, we need a web server. So there's a web server I wrote earlier here called bridge server.js, also written in Vertx. So let's take a look at that. Again, very simple. We're creating an HTTP server. There's an obvious security problem with this. You want to run this in production. I'll leave that as an exercise for the viewer. But basically, you know, we're setting a request handler, and that request handler is going to be called whenever an HTTP request arrives on the server. When it does, it's going to basically, if the request is for the root, it's just going to serve index.html. Otherwise, it's going to serve whatever's been specified in the path. And it's going to send that file back to the client side. The rest of the stuff, this creates sock.js server stuff. You don't have to worry about that for now. This is the bit that does the actual bridging of the event bus. So let's run that. Again, Vertx run bridge server.js. Again, minus cluster, because all these things could be in different parts of the network. OK. Oh, I forgot to show you the page we're going to serve. So let's have a look at the page we're going to serve first. So the page is index.html. And basically, very, very simple page. All it's going to do, it's got a bit of JavaScript in it. And the JavaScript is just going to open a connection to the event bus. And then when the connection is open, it's just using the same API to register a handler against the event bus, against the same string. And whenever a message arrives at that address, in this case, it's just going to write it out to the HTML using their jQuery, right? That's basically it. So let's actually run that. OK, and let's go to our browser, F5. And there you can see it's picking up that message that was being sent from the server side by that Scala vertical. OK. Right, so that was the event bus. Another really important feature of Vertx is we have a module system. Now, some of this might actually be changing in Vertx 3. We're having a lot of discussions at the moment about that. So kind of what I'm talking about now is the current state of Vertx. So why do we have a module system? Right. I mean, it's the same reason why anyone has a module system. It's to encapsulate the code and resources of your application into kind of chunks. that kind of makes it easier to handle them and kind of reuse them and pass them around and all that kind of stuff. So a typical Vertex application may be composed of one or more modules. In a simple application, it must be a single module that contains all your stuff. A module can contain one or more verticals. So you may have many verticals in your application. They can all go in your module. And a module has a descriptor file, a JSON descriptor file called mod.json, which basically tells Vertex a bunch of things about the module. And in the simplest case, it just has a single entry in it called main. And that just tells Vertex what is the entry point for that module. So when you run that module, what does Vertex actually have to do? Which vertical does it actually have to run? Modules also provide isolation. So we have, again, this may be changing, but for now we have class loader isolation between modules, which allows you to, for instance, say you have two different modules running your app at the same time, and perhaps they use two different versions of the same jar library. Yeah? Because we have class loader isolation and a hierarchical class loader model, they won't clash. So you can happily run those in the same JVM. So it's kind of a bit like an app server model in terms of hierarchical class loaders. And again, that might be changing to a flat class path in the next version of Vertex. But for now, we have that. So let's have a look at a module. So let me just close down the previous example. OK. Right, so I have a directory I prepared earlier. I'm just going to copy it across. OK, so now we have a directory called mods. And mods is an important directory in the Vertex module system. So when you run a Vertex module, the first place it looks actually various different places for the module, but the first place it looks is a local mods directory. And it's a bit like in the Node.js world, where it looks by default in a local directory, right? So, like I say, I've got one I prepared earlier. So let's have a look in this directory. And in that directory, there's actually another directory, which has got a really funny name. So the name, it's not actually that funny. If you've used Maven before, I'm sure most of you have had the pleasure or displeasure to use Maven, depending on your point of view. It's basically the Maven coordinates, right? So the name of the module, that directory is the name of the module. It's a unique name for the module. It's composed of 3 parts. The first part is just the Maven group ID. The second part is like the artifact ID, and the third part is like the version. So this allows us to map Vertex modules directly to Maven coordinates. So you can actually store Vertex modules in Maven, right? Now, in fact, most people do that. It's the usual place to store them. Let's have a look in that actual directory. And as you can see, this is a very simple example. This directory, this module, contains just a simple vertical called hello-world.groovy, this time written in Groovy, and a descriptor file called mod.json. So let's take a look at the hello-world.groovy. Again, it's the same example from before. The hello world HTTP example is going to output hello world from Groovy for every request that comes in. Right? Same example as before. And let's have a look at the descriptor file. Very simple bit of JSON. It's just saying, when you run this module, the thing you actually have to run is the hello world.groovy. So it's the entry point for the module. Right, so that's a module. So how do you actually run a module? The way you run it, similar to how you run a raw vertical, you do Vertx, this time it's run mod, and then you say the name of the module. So in this case, what was it again? Hello mod. If I can actually type. Right. OK, it's running. So what happened there is the first place it looked was in the mods directory. So let me actually go back to the browser so I'll prove that it's actually running. So there we go. Hello world from Groovy, right? So when we ran that, when we said Vertex run mod with the name of the module name, the first place it looked for the module was in the local mods directory. In that case, it did find it there because we just showed you it, and then it ran it from there. So let's do something a bit more interesting. Let's actually delete that modules directory. So rm-rf, rm-rf mods. And let's try and run it again. Now this time there's no modules directory, right? So what's going to happen? It's pretty quick. Let's go back to our browser. It's still running. So how did that work? So you can see there's a bit more output this time. What actually happened then, the first place it looked was in the local mods directory. This time there was no local mods directory because we deleted it. So at that point it goes, OK, where else can I look? And one of the places it will look is in Maven Central. So at that point, it found it in Maven Central because I put it there earlier. It downloaded it and installed it in the mods directory and ran it from there. So if you look now, we have a mods directory again. And it's got the same module in it, right? So that's kind of a feature of the Vertx module system. It allows you to resolve dependencies at runtime, not just at build time. Yeah? So you can actually deploy an application which is a stub, and it can just reference lots of different dependencies, which can be in Maven Central or somewhere else, and download them at runtime to create your application. And it will also download the language dependencies that you need at runtime. So if you're not, so the core Vertx distribution does not have support for JavaScript, Ruby, Groovy, Python. First time you use it, it goes, have I already got it installed? If not, it'll then go out and pull it in. So it means your distro is actually quite small, very small and compact. OK, so where are we going with the module system? So it's all about trying to create an ecosystem of modules. So, basically reuse of functionality. We want people to create modules that do this interesting stuff, put them in, the usual places like Maven or whatever. We also support bin tray, which is the new repository format. So we want to be in a situation when you write an application with Vertx, kind of like NPM, I guess, we're in the Node community, right? So you're not going to necessarily build everything from scratch every time. You're going to use this module, depending on what you're doing, piece them all together to create your application. And so far, we have most of the modules that exist. This is some examples. It's not an exhaustive list. Most of these modules have been written by the community. They're not written by the core team. Some of them are, but most of them is by the community. So you've got like kind of database stuff, like NoSQL stuff, like Mongo and Redis and that kind of stuff. We've got SQL stuff like MySQL, Postgres. We've got JDBC support. Blah, 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 various different things. RX Java support. You probably heard quite a lot about RX Java at this conference. RX Java being a cool library from Netflix, all about reactive extensions. So we have support for that too, and various other things. And the final thing I'll say about modules is we have a cool feature called fat jars. So what is a fat jar? A fat jar is, you can basically build any Vertx module into what we call a fat jar, which is basically an executable Java jar that also contains the Vertx binaries too, right? So you can then take that jar to any server that just has, as long as it has a JDK installed in it, you don't have to pre-install Vertx and it will just run, okay? So obviously that means we have to bundle the Vertx binaries inside that jar, but even that's actually a fairly small overhead. As I said, Vertx itself is pretty lightweight. It's actually a 4.7 megabyte overhead. And actually, most of that's not even Vertx. Most of that is our three dependencies that we use. So Vertx depends on NetE. We use Hazelcast for our group management for the clustering, and we use Jackson for the JSON stuff, right? So that adds up to 4.7 megabytes. The actual Vertx stuff thing is like half a megabyte or something, maybe a megabyte. So let's take a look at fat jars. OK, so let's convert that last example, that last module that we ran, let's convert that to a fat jar. So previously we ran it with Vertx run mod. So instead of that, I'm going to say Vertx fat jar. OK, let's have a look, ls. So it's now created an executable Java jar corresponding to that module. And you can take that jar, copy it any way you like, and it should just do the same thing as running that module, right? So that's how do we actually run that? Obviously, it's an executable jar. So you say java -jar, hello mod. OK. Right, so it's the first time it's encountered Groovy there, so it's basically going to download it, install it, like I said before. Go back to our browser. You can see it's still running because it's doing the same thing, right? So that's a fat jar. OK. And another important feature of Vertx is high availability. So it comes with, Vertx has HA built into it. So by high availability, I mean the ability for your application to continue functioning after failure of one or more parts of it, right? It's the usual definition. So we support failover of deployed modules in Vertx. So you can basically deploy your application in different verticals running in different places in your network, tell it to enable HA, and then if one or more of those nodes fails, then another node will take over responsibility for those modules. And you can basically partition those, you can group those nodes into logical groups. So you can say, for a particular module, I only want it to fail over between this subgroup of nodes. It's kind of flexible. We also support split brain detection, network partition detection, using the usual quorum approach. I won't go into that now. I'm sure you're familiar with that. So let's have a look at HA. Right, let's do an NHA example. So I've got another directory I prepared earlier. I'm just going to copy it over. So I've got another mods directory, and this time it's got two modules in it. One's called Groovy Sender, and one's called Python Sender. Let's take a look at Groovy Sender. Vertx Groovy Sender. Again, a very simple module with a single vertical inside it, this time called sender.groovy. Let's take a look at that. And it's the same example again. It's the event bus example from before. It's just going to send a message to the news feed, this time written in Groovy, every second. Okay? And let's take a look at the Python one. So again, the same thing, this time written in Python. Okay, right? So basically, we've got two modules there, which are doing the... Oh, what did I just do there? That's all right, sorry. Thought I deleted it by mistake. So yeah, I've got two modules there, which are doing the same thing. One written in Python, one written in Groovy. Okay, so let's run those. So again, Vertx run mod. So let's run the Groovy one first. Vertx run mod, the name of the module, Groovy Sender 10. Now, we want to run this with HA enabled. So the way you do that in Vertx, you simply put HA on the command line like that. You can use that with any module. There's no complicated XML configuration, just that's it. So let's go to another console. And let's run the Python module. Vertx run mod, IO Vertx, Python Sender 10, again minus HA. So now we should have two different modules running, one written in Groovy, one written in Python, both sending to the same address on the event bus. Yeah. And you can see it's detected a quorum that's been attained, so it's activated both those modules. So let's start up the bridge server again and try and bridge that to the client-side JavaScript. So yes, the right directory. So I'm going to run that same web server that we ran before to serve that ended HTML page. Vertx run bridge server JS minus cluster. Okay, let's go back to our browser, F5. And you can see it's working, right? So they've got two different modules running on the server side, both putting out news from Groovy, the other one's saying news from Python every second. Okay, so let's actually activate the HA. So what we're going to do is we want to kill one of those nodes, right? So they're obviously running in different Java processes, so let's kill one of those processes. So we need to find out the process ID. So let's kill the Groovy sender one. Oops. Okay, so kill -9, 7728. Find it. There, you can see that one's been killed. And you can see the other one, the Python sender, detected the other one's died, and it's taken over the responsibility for that module. So now we have the one JVM running both those modules. Yeah. So if we go to our browser, F5, it's still running. They're both still running, right? Okay. So what we can do with Vertx, we can start up an empty Vertx node running nothing at all. And the way you do that is to say Vertx -HA. So now so I'm joining another empty Vertex to the cluster with nothing running in it, okay? And then you can, and then what I'm going to do, if I can find a spare console, is we can kill the process which is now running both the Groovy sender and the Python sender and see what happens. So let's find out the process ID for that. Right, so right now, at this point, we have an empty Vertex running in one process. And we have another Vertex running that's running the Groovy sender and the Python sender. So let's kill the one with the 2 modules running in it. Kill -9, 7775. Let's go back here. That's been killed. And you can see now the empty one, yeah, has realized that's died, and it's now taken over the responsibility for both those modules. So if we go back to our browser, F5, it's still running. Okay, so that's HA, that's demonstrating HA working. Okay. And the final thing I want to talk about is, the whole kind of developer experience of Vertex. That's obviously an important thing to do. Now we realize that, well, Vertex itself is completely agnostic about what IDE or what build system you use. But we realize that kind of most people, especially in the JVM world, tend to use Maven or Gradle, or in the Scala world, SPT. So we want to basically play nicely with those things. And also we realize that probably most JVM developers tend to use IDEs, or whether it's Eclipse or IntelliJ or NetBeans or whatever. So we want to play nicely with that too. Now you can use the text editor if you want with Vertex, that's fine, or you can use Emacs or VI or whatever, or Vim. But we want to, we want the developer experience to be good with all the kind of usual tools. So we have a Maven archetype you can use. If you're a Maven, you like to do stuff with Maven, you can just create an empty Vertex project that creates a module using the archetype. We have a Gradle template, which is kind of similar. It's kind of empty Gradle project, which you can clone, and it kind of gets you started with Gradle pretty quickly. And all the kind of usual stuff for debugging and testing in IDE kind of just works. There's a kind of a nice feature with Vertex that you don't get in many other places. It's what we call module auto-redeploy. And what this lets you do is you can develop your stuff in IDE and have your module running in the background, and then when you change stuff in the IDE, it can automatically update your module, restart it, and see your changes immediately. We can have a quick look at that as a final demo. So we can probably keep those running, actually, from the previous example. And what I've got here, in another directory, what I've got here is a Gradle project that uses a Gradle template that creates a Vertex module, okay? And I've actually got it open in IDEA here. And this time it's written in Ruby. Bit of variety. And again, it's the same example as before. It's publishing every second. It's publishing to the event bus some news from Ruby, right? This time it's in the IDE and it's a Gradle project. So to run that, we provide some Gradle plugins to run stuff using Gradle. We provide a Maven plugin too, if you're a Maven user. So you can just go Gradle run mod -i for Gradle to run it. Gradle takes a little while to get going. It's not the fastest thing on the planet. So once it's running, which should be, there we go, you can now see, go back to the browser, we've now also got this vertical, this module running, this time in the IDE, that's saying some news from Ruby, okay? Now, if we go back to the IDE, let's make a change. Let's change the string to some more news from Ruby. Save it, go back to our browser, and then you can see it's updated it. Yeah, so it kind of detected that change and it redeployed that module. So it's kind of cool if you're just, as you're developing away, you can see your changes pretty quick. Okay, so this is kind of bringing me towards the end. So I'll summarize, what do we have for Vertex? It's kind of, the idea is you can write your apps as a set of loosely coupled components that can live anywhere you want. So we're getting away from this kind of application server model to a model where you can run your stuff directly wherever you want and have those bits talking to each other over an event bus, and they can live anywhere, right? You can choose the languages you want, so you use the best tool for the job. So you maybe have like some sort of webby stuff that you want to do in JavaScript. You maybe have a JavaScript team. That's what they know. they can do that. Maybe you have some sort of back-end logic you prefer to use a statically typed language like Java or Scala for, okay? And you can do that. So we're not kind of restricting you on the language, which is a kind of big win, say, over Node. Again, it's a very simple concurrency model. We have a kind of actor-like concurrency model, you know? And because of that, you can write your verticals a bit like kind of like, they're not really actors, but they're kind of like actors. You can write them as single-threaded. So you don't have to worry about, a lot of race conditions simply don't happen. You don't have to worry about, you know, explicitly locking stuff. A lot of deadlock conditions simply don't happen, okay? We have a module system, so we want to have a situation, we have a library of modules, kind of like NPM, where you can just piece them together to do what you want, depending on what your application is. We have NHA and ease of development. We're kind of still working on the ease of development's not perfect yet, but we're kind of getting there. It's kind of a hard job because you have to support so many different like IDEs and build tools, and everybody has a different idea of how things should work, so it can be difficult at times. Yeah, so I'll finish off just a bit of information about the project in terms of like governance and that kind of stuff. I work for Red Hat, but the project is not owned by Red Hat. The project is actually an Eclipse Foundation project, so all the trademark and the IP is all governed by the Eclipse Foundation. All the code is on GitHub. We work exclusively on GitHub. 100% open source, of course. ASL2 currently. Actually, we're dual licensed, ASL2 and EPL1, because we're an Eclipse project, and that's how they like it to be done. And we're currently we're still one of the most popular Java projects on GitHub. I think we're like number 10 or 11 out of all Java projects on GitHub right now. So, having said that, we have a very, very small team, and we have a very small core team. We have a good extended community, and the community does a lot of stuff. However, Vertx has a very big scope. Obviously, it's kind of, there are so many different things you could do with it, so many different modules that could be written. So there's loads more to do. So if you're interested in getting involved, come and see us on GitHub, come to our Google group. That's where most of the discussions happen. And we have an IC channel too on Freenode, so you're welcome to drop by there. And if you want to help out, that'd be cool. And that's basically it. I hope you enjoyed the talk. Any questions? Question at the back there? Oh, sorry, at the front. Do the front first. Yeah.
You showed the event bus being listened to from the client side. What support is there for locking down what you can and can't access in the event bus from the client side? Right.
So yeah, so the question is, the event bus can be accessed from the client side. So obviously, there's potentially a massive security hole there. You don't want everything to be exposed to any client, right? So we have a kind of a firewall of sorts, basically, that you can provide. So we have you can basically specify what kinds of messages can be passed between different addresses. So it's kind of pattern matching you do. So basically, you can lock that down effectively. Yeah. Question in the middle there.
So when you showed the HA stuff, things would migrate from one node to another. But how do they get back? So, like, if you had a node running 5 verticals, another node running 5, and one dies and they all shift to one, and then you start up an empty one, how does would it rebalance itself, or?
No, we don't. So the question is, with the HA, do we have any kind of automatic failback, right? And there's no built-in failback currently, so you have to manually restart stuff on whatever nodes you want to start it on.
Would it migrate back to the original node? Like if you started it up on another node, would it get off the node it was on?
No, so currently it wouldn't, no. So you have to manually shut that down. So what we want to do in the next version of Vertx is have much more kind of, basically do a lot of stuff with kind of monitoring and sort of basically provide tools that let you deploy stuff on different nodes and shut things down and start things up and move things around, all that kind of stuff that you typically might want in production situation, yeah. Any more questions? There's a question at the back there, just.
So if an exception is thrown while handling a message, is there any retry capability?
Okay, so right now, so this is, no, there isn't currently, so you have to build that yourself. Again, this is another feature we're working on the next version of Vertx. We want to kind of do a supervisor-like model, a bit like what you get in the actor model, in Erlang or Akka or whatever. So we want to have a situation where you can, if exceptions are thrown, we can have a particular policy which can kick in and maybe restart it up to a certain number of times or propagate that back to the supervisor, that kind of thing. So right now you have to handle that yourself. Question here?
So you have like an evented model with a number of threads behind that evented model. What's the story if you try to include a library that maintains its own thread pool or blocks?
Okay, that's a good question. So, yeah, so in an ideal world, everything will be non-blocking, right? But the reality is we don't live, especially in the JVM space, we don't live in an ideal world. And most Java APIs tend to be blocking APIs, like JDBC is a good example, and many, many others. So we need a story to deal with that. So you can't expect to rewrite everything overnight asynchronously. So in Vertx, you have the concept of a worker vertical. So a normal vertical runs on an event loop, but you can specify what we call a worker vertical. And a worker vertical actually runs on a thread from a thread pool. Yeah. So you typically use worker verticals if you need to access any, basically if you need to block. So the blocking might mean, talking to a blocking API like JDBC, or it may be doing a long-lived computation, or anything that really kind of, stops the event loop, stops the thread from running in wall clock time. Yeah. So that's how we deal with it. We have what we call a worker vertical to deal with that. A question down here?
If I want to build a cluster of applications for high availability and scalability, what's the relationship between HA mode and running in a cluster with Vertx? Okay,
so when I say cluster in Vertx, it basically means the nodes form it's a clustered event bus, right? So the different nodes form this clustered event bus. There's no actual HA built into it. When you have HA, you have to have clustering, so it's like HA requires clustering, but it kind of adds stuff on top. It adds the HA on top.
And all the communication between the nodes is via Hazelcast?
Okay, so we use, actually, the cluster manager, what we call the cluster manager is actually completely pluggable. So it's abstracted out behind an SPI. The default implementation uses Hazelcast, but you can actually implement a few interfaces, then plug in, say, Zookeeper or whatever you want to use. It's actually a very simple API you have to implement. So we use the cluster manager, so by default Hazelcast, we use that purely for the group management. So it's the thing that kind of forms, tells each node where every other node is. We don't actually use it for the transport. So once we know where a node is, we form direct TCP connections to that node. Okay? Because it's much faster doing that than going through Hazelcast.
And just one quick last question. With the cluster communication, I assume you can give it some kind of namespace so that if you want to partition different clusters so they don't talk to each other.
Yeah, I mean, so you can so basically our addressing is a simple string, so you can do anything you want in there. So you might actually create your own naming scheme like something dot something, whatever. So you can have logical kind of clusters, although they'll still be the same cluster. If you want actual separate physical clusters, then you could basically run, you can start different nodes on different ports, and then they would form different clusters. Yeah. Okay. So you could actually manage more than one cluster in the same network if you wanted to, and then you could do you can then configure it differently depending on the network and all that kind of stuff.
Thanks.
Okay. Okay. Thanks everyone. Hope you enjoyed that.